All right. So, see if I can rearrange my screen here a little bit. Okay. So this is lesson one of our sequences and functions. Um, it but got about 10 slides here, but a couple of them are just title slides like we have here. The This unit is actually derived from something called illustrative mathematics. It's spelled just like illustrative. I don't know why they call it illustrative, but it's a curriculum that we're actually considering using in the future. But I'm gonna just pick a couple different units as we go through the second semester to work through with you guys because they tie right along in with some of our algebra 2 topics. Um, go ahead and click along here. So the thing we're going to be exploring today and working with our sequence is something called a Tower of Hanoi. It's actually a game. It's a game puzzle, uh, but we're going to use it to talk about a different sequence, a sequence of numbers. Okay, so let's first of all talk about making a list of numbers. So when you think about sequence, we're thinking of kind of a list of numbers that goes on forever. All right, based on a rule. Okay, so based on a rule. So here's a rule we have here. It says each number is one less than twice the previous number. Okay, each number is one less than twice the previous number. So I'm going to ask you guys just on your own, pick a number to start with, then follow the rule to build a list of 5 numbers. Okay, so what I'm going to do is I'm going to go ahead and move that up. I'm going to go ahead and start with a number. I'm going to pick a number. And I'm going to pick number 7 to start with. Okay. 7. So let's see. Each number is one less than twice the previous number. So this next number right here after 7, it's one less than twice the previous. So twice the previous number is of 7. So 7 times 2 is 14, and one less would be 13. So that'd be my second number because 13 is one less than twice the previous. All right, well, let's do this with the next one. I'm going to double 13. That's 13 times 2 is 26. 26 minus 1 is 25. Okay, there's my third item. Let's see, double 25. 25 times 2 is 50, minus 1 is 49. And if I want to get the fifth number in the sequence, I got a double 49. 22 times 49 is 98, minus 1 is 97. Okay, so if I wanted to make a sequence, okay, and this would continue on forever. So I could put the 3 dots there. This could continue on forever. I've just got the first 5 based on the number I picked to start with. Okay, now we could have picked any number to start with. Okay, in this situation, okay, we could have picked 1 or 0 or a negative number. Um, it really, we could have picked any number. I just chose to pick 7, and this is the sequence of 5 numbers I got based on starting with 7. Okay. A lot of times I'm going to give you guys our starting point with these, um, and then we'll be working from there. But if it's open ended like this, you can pick whatever you want. It might be easiest to start with 0, okay, or start with 1, numbers that are pretty low. But you can see these numbers are going to get big pretty fast because we're doubling and just subtracting 1 from it. So like our next number is going to be 193. So they're getting big pretty fast. All right. I apologize. I got to erase everything before I move to the next page. All right. I am not, you guys don't have to read all this. Okay. You don't have to read all this, but here is the situation we're working with. It's called the Tower of Hanoi puzzle. And you guys, when I saw this puzzle, and I've seen this puzzle before, but when I see it, I think of actually a little kid's toy that's got like the plastic rings that go one on top of the other. Um, and a lot of times you end up rearranging them and put like the smallest one on the bottom all the way up to the biggest. Well, what we're trying to do in this puzzle is you're trying to move these 4 different size rings on the left pole over to the right pole in the same order, from the biggest on the bottom all the way up to the smallest. Okay, you can only move 1 disc at a time though. Okay, you can only move 1 disc at a time. And you can never put a larger disc on top of a smaller one. All right, so you got these 3 poles that you can put them on, but you got to follow those 2 rules. Only move 1 at a time, never put a larger disc on top of a smaller one. Okay, now what we're going to do is we're going to try and answer these questions. Okay, now I'm going to help you guys out a little bit, and we're only going to go through the first few of these situations, and then I'll give you the last couple of them, because they do end up taking quite a bit of time. They're easy to start with, but then they get pretty hard. Okay, so I'm gonna move to the next slide because there's actually a little activity here. I will be sharing these slides with you as well. So if you want to try these activities on your own, you're going to be more than I would recommend it, because 1, I think they're kind of fun, and 2, it'll help you when you're determining these different sequences. All right, so this next slide actually shows the little puzzle, and the nice thing is, from within this little puzzle, you can actually go ahead and perform this. You just click on it, and it takes you to a link. Where'd it go? I think it's loading up. There it is. Shows this little link right there in the middle. All right. And it actually allows you to, when you click on one of the poles and then click on the other one, it moves it to that pole. And I like to do the show count because it shows you how many moves you've made. All right. So if I want to complete this, here, let me reset it. It starts like this, and I need to make it the right side look exactly like this now. Okay. I need to move these 2 blocks or these rings over to here. So I'm going to do, that's 1 move, 2, 3. So, and once you do it, it tells you solved it. 3 moves. Now the goal here is we're trying to get in as few moves as possible. I don't think I could have done that any quicker. Okay, 3 moves to get from the left to the right. Now, if I move this slider over, now I've got 3 of these. Okay, this one's a little bit harder. Okay, a little bit harder. And it took me a little bit of playing with it, but I think I've got it down to the least you can do here. Where I'm moving these 1 at a time, and I got 7 moves. Okay, and I was able to get it down to 7 moves. So again, trying to go from the left side to the right side, I was got 3 moves when I had 2 discs. I had, let's see, 7 moves when I had 3. 4th one took a little bit longer, and I'm probably not going to get this one exactly right. Here, I'm resetting. I think I'm supposed to go here to start. There we go. And now once I get this big one, I need to move that. That's going to be the first one on the right. And I still don't think I did it right in the least number. All right, but I got 17 moves there to get it back over there. Again, there's multiple ways to do this, but for this puzzle, we were trying to find the least number. If we had a little more time and I'd feel a little bit more comfortable if we were doing this in class, I'd probably have you guys all try these and try and figure out, all right, who is able to get the least number, so that as a group we can work together to find the least number of moves to get from the left to the right. Okay. Go back here. All right, so our goal here is we're trying to fill in all these different blocks here. Okay, now we did figure out that When we had 2, it took us 3. Okay. I apologize. I'm communicating a little bit on my other computer at the same time, but we'll get through this. We had 3 for 2, and I believe it was 7 was the least number we had for 3. This one wasn't filled out where we had 1 disc. If we only had 1 disc here, how many moves would it take to get to the right side? Well, since it's only 1 disc, in 1 move, you can get from the left to the right. Okay. We could be done in 1 move if you only had 1 disc. All right. Now, if we were to continue on with these, all right, and again, these get pretty intense here, but if you were to continue on, the least number of moves we could get for 4 would be 15. When we move to 5, it would be 31. When it moves to 6, it would be 63. And when we go to 7, it'd be 127. Now, we're talking about something, this is going to take us a while, 127 moves, and there's no way we're probably going to get that done on the first try. Okay. Even the 63. These get pretty tough to minimize your number of moves. Okay. But there is a pattern as we move from one sequence from the 1 disc to the 2 disc to 3. There's a little pattern here that goes with this. All right. And if we look, what we see here is like this number goes up. Like a lot of times I look at addition and I say, all right, this number goes up 2, this number goes up 4, this number goes up 8, this number goes up 16. So your pattern could be it's doubling the number that it's going up each time. Okay, you're doubling the number. We like to look at how the number how it's changing. If we can do like a mathematical expression, a lot of times it helps. Like if I look at the sequence, like this is the first item in the sequence. Well, if I double this, okay, if I double this and add 1, so 1 times 2 plus 1 is 3. 3 times 2 plus 1 is 7. 7 times 2 plus 1 is 15. And that's the third item. So a lot of times I look at it like that's another way you could look at it is it's doubling, then you're adding 1 from the previous. So there's a few different ways to do that. Okay. But this is the sequence we end up with 1, 3, 7, 15, 31, 63, and 127. There it is. All right. Now, I want you guys also to be able to generate these sequences as well, because it's going to help you in understanding them. Okay. So here's a sequence that starts 3, 6. I want you guys to think about a rule that the sequence could follow and list the next 3 terms. Okay. Think about a rule that the sequence could follow and list the next 3 terms. I'm going to give you guys about 30 seconds to think about a rule. All right. And then just think about what those next 3 terms could be. If you got your pen and paper or pencil and paper with you, just write down what you think your next 3 are. There is no one correct answer for this. Okay. There are multiple ways for this to be correct. The key to it is just stating your rule and then sticking with it. All right. I'm going to go ahead and think of a couple different rules here. Oh, let's get pen out. Let's go back. All right, let's try this again. So a couple different rules. So here's one rule that I looked at that I think the first one that I thought of, I'd see it went from 3 to 6. Well, in my eyes, all right, I doubled it. So maybe we're doubling every time. So we start with 3, well, double previous term. Okay, let's make that our rule. And then the sequence would go 3, 6, 12, 24. I'm just doubling every time. 48. And then it would keep going. Okay, so that could be one. That could be a rule. Um, Another rule we could use, maybe we're adding 3 each time. Okay, so we go 3, 6, 9, 12, 15. There's our first 5 terms. Okay, so maybe we're adding 3 each time. These are probably the two most straightforward. I'm sure you could do a lot of others with these. Okay, um, but these are the two that I think pop out the quickest for me. Whether you're adding 3 or doubling. Um, Again, if you got anything else, then as long as you're being consistent with it, then you're going to be good to go on this example. Okay, but these are the types of things we're going to be working with here with our practice problems that we're going to work on tomorrow. Okay, these types of sequences. So the two terms that we're going to be using a lot, especially this first week. So sequence, that's just a list of numbers, it possibly going on forever, such as like all the odd integers arranged in order. So integers are whole number, positive or negative, but this is a list of the positive integers arranged in order. So that are odd. 1, 3, 5, 7, 9, 11. So just going on to infinity, just going up by the odd numbers. This is an example of a sequence. Okay. The two examples we had earlier were sequences, and they're sequences that could go on forever. Okay. They don't have to go on forever. They may say, what's the sequence of numbers that are less than 100? Okay, and give some stipulations. We could be working with a real world situation where we are limited to the number of things that we'll have access to. Okay, in that case, then your sequence wouldn't go on forever. It'd be limited by a certain number. Okay. The other glossary term we have here is term. Okay, and when we're talking about a term, we're talking about the term of a sequence, and that's just one of the numbers in a sequence. All right. So just like with the Tower of Hanoi, we had 1 through 7. Well, we had 7 different terms there. Okay. And we could talk about specifically about the terms based on the number of rings that we were using. Okay. So if we had 4 rings, that was going to be the 4th term in the sequence. Okay. Right.